Welcome viewers. In this video we will see the details about inverse hybrid G parameter in the two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic two-port network. Under that, inverse hybrid G parameter. First we will see the two-port network, the block diagram of the two-port network. So this is the two-port network, input port and output port. 1 dash input port, 2 dash output port. V1 and I1 is the current voltage and current in the input port. V2 and I2 is the voltage and current in the output port. So then normally we have open circuit impedance parameter, short circuit admittance parameter, two type available. In that we will take the V1 I1, that is the voltage and current in the input port, as a dependent variable. V1 and I1 is dependent variable, that is expressed in terms of V2 and I2 is independent variable. So V1 I1 are expressed in terms of V2 I2 in the open circuit impedance parameter and short circuit admittance parameter. So the hybrid parameter means one variable from input port, one variable from output port is taken. So that is called a hybrid parameter. That is V1 from input port and I2 from the output port is taken as a dependent variable, that are expressed in terms of I1 and V2. V1, I2 are expressed in terms of I1 and V2. So inverse hybrid means just opposite. I1 and V2 are taken as a dependent variable, that is expressed in terms of I2 and V1. So that is given. I1 and V2 taken as a dependent variable, that is expressed in terms of V1 and I2. That's why it is called a inverse hybrid parameter, right? So in the normal case, V1 I1 dependent variable. In the hybrid case, V1 and I2 is the dependent variable. Inverse hybrid means I1 and V2 are the dependent variable. Now we'll see the detail. In hybrid parameter, the voltage at the port 1 dash and current at the port 2 dash are taken as a dependent variable. So in inverse hybrid parameter, the current at the input port I1 and voltage at the output port V2 are taken as the dependent variable, just opposite of the hybrid parameter. So that we'll see the equation. So I1 equal to G11 V1 plus G12 I2. Similarly V2 equal to G21 V1 plus G22 I2. So G11, G12, G21, G22 are called the hybrid inverse hybrid parameters. H11 means hybrid parameter, G refers inverse hybrid parameter. Now we'll see how to find these four parameter. What is the procedure? So this coefficient in the above equation are called a inverse hybrid parameters. Coefficient means G11, G12, G21 and G22. That is given in a matrix format. I1, V2, that is the input. That is expressed in terms of V1 and I2. The coefficients are G11, G12, G21 and G22. Right? So this is the given in a matrix format. So this is equal to equal. Now we'll see the relation between hybrid and inverse hybrid. So the determinant of this hybrid parameter, inverse matrix of hybrid parameter equal to the inverse hybrid parameter. Hybrid parameter inverse is equal to inverse hybrid parameter. By taking the matrix inverse, we'll get the hybrid inverse parameter. Now we'll see how to find these four parameters one by one. So this individual G parameter may be defined by letting I2 equal to 0 and V1 equal to 0 by substituting in equation 1 and 2. That is, what is that? We are making I2 equal to 0. That means open circuited. By making the output port is open circuited, voltage will be there, current is 0. By making the input port short circuited, current will be there, voltage is 0. So first we will take I2 equal to 0. That means output port is open circuited. So there is no current in the output port. I2 is 0. By substituting this I2 equal to 0 in equation 1 and 2, we are able to find the first two parameters. Now we will see the equation 1 and 2. So this is the equation 1 and 2. I1 and V2 is expressed in terms of V1 and I2. Now what we assume, I2 is 0. Output port is open circuited. These two terms are 0. If I2 is 0 means the entire term is 0. So that what we have, I1 equal to G11 into V1. Bring this V1 in the denominator. So I1 by V1 equal to G11. That is G11 equal to I1 by V1. Similarly, I2 equal to 0 means this entire term is 0. What we have, V2 equal to G21 into V1. So G21 is nothing but brought this V2 in the denominator. V2 by V1. G21 is V2 by V1. Now we'll see the expression. Right. Now the I2 is equal to 0. We verified with the equation. What we got? G11 equal to I1 by V1 by making I2 equal to 0. What is this G11? Open circuit input admittance V by I. So that it is admittance. Input is there, 1 input port. So it is the input admittance. We already open circuited. So that open circuit input admittance. So that is equal to 1 divided by Z11. In case of Z parameter. In Z parameter is nothing but open circuit impedance parameter. These two are equal. G11 equal to 1 divided by Z11. Similarly, what we calculated, G21 equal to V2 by V1 by making I2 equal to 0. So both are voltages available. So it is a voltage gain. So already open circuited. So open circuit voltage gain. Right. So by making output port open circuited, I2 equal to 0, that is substituted in the general equation, we are able to find G11 and G21. Now we'll go to the next part, V1 equal to 0. By making input port is short circuited. Short circuit means current will flow but voltage is 0. Now we'll substitute V1 equal to 0 in the general equation, so that we are able to find the remaining two inverse parameters. Now we'll see the general equation. Right. So here what we are doing, V1 equal to 0. Input port is short circuited. So V1 is 0. If V1 is 0, this entire term is 0. Only we have I1 equal to G12 into I2. Brought this I2 in the denominator. So that G12 equal to I1 by I2. Similarly, V1 equal to 0 means the entire term is 0. What we have, V2 equal to G22 into I2. Brought the I2 in the denominator. V2 by I2 is nothing but G22. Right. So by making V1 equal to 0, we are able to find G12, that is equal to I1 by I2. G22, that is V2 by I2. Now we'll see the expression. Right. So by substituting V1 equal to 0 in the general equation, that is input port is short circuited, what we got, G12 equal to I1 by I2 by making V1 equal to 0. See, both are current is there. So it is current gain. So reverse current gain and short circuited. So short circuit reverse current gain. Right. Next term is G22, V2 by I2 by making V1 equal to 0. V by I means impedance. V2 by I2. So at output impedance. Short circuited. So short circuit output impedance. That is equal to 1 divided by Y22. Short circuit admittance parameter. Y is nothing but admittance parameter. So G22 equal to 1 divided by Y22. So now we were able to find all four inverse hybrid parameters. So first the inverse hybrid means input voltage and output current is the dependent variable. Hybrid means input current and output voltage is taken as dependent parameter. First we substituted output port is open circuited, making I2 equal to 0. We are able to find G11 and G21. The second case, the input port is short circuited, so that the current will be there and voltage V1 is 0. By substituting V1 equal to 0 in the general equation, we are able to find G12 and G22. So the all four parameters are calculated. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.